Okay, right. In this class, we'll try to solve some of the questions based on whatever we have done so far. First question is sin x greater than 0. You can solve this question even without drawing the graph, but I would prefer to solve this question using graphical approach. So sin x greater than 0, which means y1 is sin x. So I have drawn sin x, and then second graph is 0, y2 equals 0. One of the graphs is sin x and other one is y equals 0. The point of intersection is n pi, minus pi, 0 pi, 2 pi. Sin x greater than 0 part which is over this y equals 0. Between 0 to pi, sin x is positive and period of sin x is 2 pi. So we'll be adding 2 pi, 4 pi, 6 pi. Solution to this problem is 0 to pi, 0 to pi, and then plus minus 2n pi, plus minus 2n pi to cover entire range. N is integer. Second question, sin x greater than half, which means I'll be drawing two graphs. One of the graphs is sin x and the other one is y equals half, straight line parallel to x-axis. This is sin x between 0 to pi, 0 to pi, first and second quadrant, because sin x is positive, we don't need to cover the negative part of it. Sin x equals half. Solution is either you can say x equals n pi plus minus 1 raised to power n into pi by 6. If n equals 0, first solution is pi by 6. If n 1, pi minus pi by 6, 5 pi by 6. So you can do it using symmetry, because pi by 6 is obvious, this length is pi by 6, this has to be pi by 6. Graph is purely symmetrical about this midpoint, pi by 2. This is pi by 2. So pi by 6, between distance between 0 and pi by 6, likewise distance between this point and pi is pi by 6, point is 5 pi by 6. Therefore solution is this particular part of sin x, which is over y equals half, pi by 6 to 5 pi by 6, and then entire range plus minus 2n pi. Another question is, suppose we want to solve sin x greater than cos x. Now we again be drawing two graphs. One of the graphs is sin x and the other one is cos x, and then period of both sin x and cos x is 2 pi. So I'll be drawing the graph of sin x for 0 to 2 pi and cos x 0 to 2 pi, and then we can do the same procedure here. So green color is this one is sin x 0. This orange one is sin x 0 to pi and then pi to 2 pi. This one is cos x. At the point of intersection, y coordinates are equal. You can solve this question using symmetry, or at these points sin x equals cos x, which means tan x equals 1, which means x equals n pi plus pi by 4. If n equals if n equals 0, first solution is pi by 4. This point is pi by 4. If n equals 1, then pi plus pi by 4. This point is 5 pi by 4. Sin x greater than cos x. Orange part which is over this green part, which means this. So solution is pi by 4 to 5 pi by 4. And then 2n pi. So pi by 4 to 5 pi by 4, and period of sin x and cos x both is 2 pi plus minus 2n pi to cover the entire range. You can also solve this pi by 4 and 5 pi by 4 using symmetry. The graph is increasing from 0 to pi by 2 and this one is decreasing from 0 to pi by 2. And symmetric graph is increasing and decreasing at a very symmetrical rate. Point of intersection has to be midpoint, pi by 4. Okay, maximum of tan inverse and cot inverse x. We have already done sin inverse and cos inverse. Maximum of tan inverse and cot inverse. So we'll be choosing the graph which returns maximum value. For this we need to understand where they intersect. First thing is, this one is cos x, tan inverse x, this one is tan inverse x, pi by 2, this is minus pi by 2, this point is pi. This purple color is tan inverse and this green color is cot inverse. Point of intersection is again midpoint, this pi by 4. At point of intersection, both the y coordinates are equal, pi by 4, which gives us 1, because tan inverse pi by 4, tan inverse pi by 4 will return you, tan inverse 1 will return you pi by 4. So 10 pi by 4, this point is pi by 4. Okay, tan inverse, and we need to draw maximum. So this part is below this green one, and then this part is below this purple one, which means from minus infinite to 1, cot inverse x is maximum, and from 1 to infinite, tan inverse x is maximum. So this is tan inverse x 1 to infinity, and cot inverse x minus infinity to 1. Okay, at point of intersection, which means x equals 1, both the values are equal, so you can apply greater bracket here. Now number of solutions to these 4 questions: sin x equals x by 5, x by 10, x by 100, cos x equals mod of x by 10. Okay, let's do this question. One of the graphs is trigonometrical and the other one is polynomial, straight line. Solution method, there is a branch of mathematics which deals this kind of problem, numerical analysis, but that's not our concern. Okay, so sin x equals cos x, number of intersection. So what we do, we draw sin x, which is a repetitive graph, and then x by 10. Now interesting thing is, this function is bounded function and range of this function is -1 to 1, which means the only possible solution will lie when this right hand side is between -1 to 1. Tentatively, minus 10 will give you something close to 3 pi, slightly more than tentatively, I can say any point close to 3 pi, but on the right hand side of it. So this value is 1. So graph of x by 10 will pass through in a way this. And after this point, there is no u to consider it because the graph is going beyond 1. Okay, so 3 points. This is a solution, this is a solution, this is a solution, and x equals 0 satisfies this. Sin x is symmetrical about origin. Likewise, x by 10 is symmetrical about origin, which means if there are 3 solutions this side, then 3 will exist on this side. So 3 plus 3, 6, 1, 7. This has got 7 solutions. Now sin x equals x by 100. So important point is x equals 100 and minus 100, which means 30 pi is close to 90, 31 pi, 32 pi, 33 pi. So that way you can, so number of loops above x-axis are important on that side, and number of loops below this x-axis are important on this side. And I leave all the questions to you, but there is nothing much to do. Number of solutions to some questions on signum function. Okay, so signum of x square plus x plus 1 equals this. Now this is strictly positive. Perfect square plus 3 by 4. So this value is greater than 0, which means if this value is strictly greater than 0, signum of this will return us 1, which means 1 equals x square plus x plus 1. Solution is -1 and 0. It's very easy question. Second question, signum of sin x equals x, number of solutions. Now signum of sin x will return us 1 provided sin x is positive, which means first quadrant and second quadrant. Sin x will give us 0 whenever sin x is 0. I mean signum of sin x will return 0 whenever sin x is 0, which means 0, pi, 2 pi. Okay, -1 in third and fourth quadrant, so pi to 2 pi. Because period is 2 pi, so I need to consider only from 0 to 2 pi. First quadrant +1, third quadrant, fourth quadrant -1, and 0, pi, 2 pi value is 0. This is the graph of signum of sin x. This is +1, this is -1, period is 2 pi, this is 0 to pi first quadrant, pi to 2 pi third and fourth quadrant, then again the rest of the things are easier. So draw y equals x. Y equals x will pass through this point, this point we need to exclude, which means the only possible solution is x equals 0. X equals 0 is the only solution, only one solution. Now signum of cos x equals signum of e raised to power x. Exponential functions are always positive. Exponential function is always positive, which means signum of e raised to power x will return us 1, a constant function throughout. This is signum of e raised to power x, which means the only possible solution will lie in a region when this part gives us 1, which means minus pi to pi by 2, fourth quadrant and first quadrant, cos x is positive, so plus 1, this value is plus 1, this value is minus 1, minus pi by 2 to pi by 2, this will return us 1. At these particular points cos x is 0, which means signum of cos x is 0, these dots, and then pi by 2 to 3 pi by 2, this value is negative, no point considering it. Solution lies whenever this part is positive, minus pi by 2 to pi by 2, and then period of cos x is 2 pi, which means 2n pi. I hope this is sufficient for you to understand how do we actually solve these questions and rest of the things in my next video.